Here's a calculus free response question. The velocity of a particle p moving along the x-axis is given by the differentiable function v of p in meters per hour, and t is measured in meters per hour, t is measured in hours, right? That makes sense, that they're the same unit. Selected values are shown in the table above, so it's going from 0 and then 55, and then at some time later it's going in the negative direction pretty fast, and then all the way back up to positive, and then positive but less. Okay? So this thing definitely turns around a couple times, right? Because it's going in the positive direction, then negative direction, then positive again. So particle p is at the origin at time 0. Okay? Justify why there must be at least one time where the acceleration equals 0. So the acceleration is the slope of this, and if this is a differentiable function, and this is really like a mean value theorem question here. So since Vp of t is differentiable, mean value theorem says that average slope must equal the actual slope. And then what interval do we want to pick? We want one where the average slope is 0. So 55 to 55 is going to give me a slope of 0. So that's on the time interval from 0.3 to 2.8. Right? It says that the average slope is equal to the actual slope somewhere in there. And the average slope is 55 minus 55. That's meters per hour over 2.8 minus 0.3 hours, which is equal to 0, which is equal to Vpt, which is, and of course the derivative of that is the acceleration. And there's different ways you could say all that stuff. The things that are absolutely 100% necessary is you have to invoke the mean value theorem, which means you have to refer to the fact that this function is differentiable, and then mean value theorem applies. So there you go. Part B, use a trapezoidal sum with the 3 subintervals, these 3, 1, 2, 3, to approximate the value of this integral. Okay? So to do trapezoids, we have to do the width of the trapezoid divided by 2 times the sum of the 2 different heights at the edges. That's, I think, the best way to set it up. The width here would be 1.4 divided by 2, and then the sum of those 2 things. The width here is at 1.1, and then the sum of these 2 things. All right, I think that looks good. And now we just need to crank that out of the old calculator. So 0.3 divided by 2 times 55 plus 1.4 divided by 2, and 55 minus 29 plus 1.1 divided by 2, negative 29 plus 55. That's all good. That is 40.75. And the units of this is the area under the velocity, so that is going to be a displacement. And our units there are meters. Right. On the scoring guide for this one, they don't have a point attached for having the right units, but sometimes they do. Usually they say in the question, include units, when they have a point attached to it. Part C, a second particle, Q, also moves along the x-axis. Its velocity from time 0 to 4 is given by this. Find the time interval during which the velocity of particle Q is at least 60 meters per hour. Okay, I'm just going to do that first. So there's different ways to do that. I'm going to do it by graphing. So I'm going to graph, oops, I'm going to graph nothing there. I'm going to graph this 45 times the square root of t times the cosine 0.063 squared. All right. Before I hit graph, and I want to know when it's at least 60. So I'm also just going to graph the horizontal line at 60. So before I graph anything, I'm going to go to the window and think about what I want here. The time intervals, or the time interval that I'm interested in, is 0 to 4, right? And if I'm going up to 60, then maybe here 0 to, I don't know, 80. Could do 100, just guessing something. If it's not a good choice, then I can always go back and change it. Looks like a decent choice. All right, so you can see right there, that's when the velocity is greater than 60. So I'm just going to go ahead and find those intersections. 1.866. Find the other one. If there's multiple intersections, you just have to get the cursor closer to the intersection that you are interested in, and then play the game. 3.519. All right, that looks good. And then find the distance traveled by the particle q during the time interval when the velocity... Okay, so I want the distance traveled by q on that time interval. If you want total distance traveled, you do total distance is equal to the area under the velocity function. And if you want total distance, you should put it in absolute value signs. Now, in this problem, we just looked at this, and these velocities are all positive, so you don't actually need those absolute values. You would be okay without them. But if you have a velocity function that changes sign and you want total distance, then you need the absolute value signs. And it doesn't make it wrong to have them here, so I think it's probably not a bad idea to include them. All right. So now I want to do, since I have this graphed, I can do this right on this screen. I can go second calculate number 7. And I want to go from 1.866 to 3.519. and it finds that area for me, which is 106.109. Great. And that would be in meters. Part D. From part B, the position of particle P at time... Oh, sorry, I'm reading the wrong thing here. Where am I? At time t, there we go, particle Q is at position x equals -90. Use the result from part B and this function from part C. Approximate the distance between the particles P and Q at time 2.8. Okay, so the position, we call x of P at time 2.8 is, I know I found in part B this trapezoidal sum, and this, since it's starting at the origin, this is the position at time 0. If it didn't start at the origin, I just have to add that initial value, so I didn't make the fundamental mistake of calculus. Sorry, that's not at 0, that's at 2.8, that's what I meant. Right, that's what we found when we found that area. So that's approximately 40.75. And now I want to find the position of Q, particle Q. How do I do that? Well, I've got a velocity function for it here, and I know its initial position, so that's fundamental theorem of calculus right there. I know that the integral from 0 to time 2.8 of the velocity function is equal to position at 2.8 minus position at 0. Right? Trying to find that. And I know that this is -90. So minus -90 would be plus 90. And then that I'm just going to find here because I have my VQ right there. So I just need to go back to here and do this again. Number 7. Now I'm going to find the area from 0 to 2.8. And that's 135.938. 135.938. You want the position at Q. Just have to subtract the 90 there. Okay. So the distance between them, distance is always positive, right? So the distance between these two at time 2.8 is the difference between those two numbers, which is 5 and change, 45.938 minus 40.75 is about 5.188 meters.